Now we are going to open the element at the end of the linked list. Okay, so we have had this one, and this is the first one. So second, this is the third. So this is the next. Okay, so our linked list is one arrow to one. Okay, so this is my linked list. I want to add new element at the end of the linked list. Okay, so here you can see new node equals to this one. Okay, this is the node. After that, traverse till the end of the linked list and assign last node last node this one equals to last node equals to next last node dot next equals to new node. Here you can see this is the new node. Linked list after the insertion element. Okay, so it become like this 1, 2, 3 and 4. Okay, so you can see here. So here this is the append method. We are going to pass self and value. So new node equals to node. This is a node class of linked list. Okay, so self dot head is none. Okay, if self dot head is none. So self dot head equals to new node. Okay, because we are going to append the node. Okay, so here if we don't have any element or it will be none, then we need to write like self dot head equals to new node. This is the first node, and this is also head and this is also same. Okay, so after self dot head equals to new node and self dot tail equals to new node. Okay, so if self dot head is none, we will write this condition. Otherwise, in else, we need to uh, write this condition. Okay, so self dot tail. Here you can see self dot tail dot next. Okay, here in this diagram you can see this is the tail. Okay, this is the tail. Self dot tail. Okay, self dot tail dot next. Okay, self dot tail dot next. Self dot tail dot next equals to new node. Okay, here you can see self dot tail dot next equals to new node. Now self dot tail equals to new because it become a new tail, this one. So that's why self dot tail equals to new node. We are going to update self dot tail equals to new node and self dot length we can increase one. Okay, so here you can see appending 10. Here you can see appending 10. List is empty. Head and tail will point to a new node. Okay, in starting list is empty. Now we want to append 10, then head and tail point to a new node equals to 10. So linked list equals to 10, head equals to 10, and tail equals to 10, and length equals to 1. After that, we are going to append 20. So now list not empty, tail equals to 10, and tail equals to 10, and tail dot next equals to 20. So linked list 20, 10, comma, 10 arrow 20. So head equals to 10 and tail equals to 20 and length equals to 2. Here you can see appending 30. So list is not empty, tail equals to 20 and next equals to 30. So linked list equals to 10 arrow 20 arrow 30. So head becomes 10 and tail becomes 30 and length is 30. So here you can see this is the append method in linked list. Now we are going to move prepend method. Here we can add elements in the beginning of the linked list. So here you can see this is the method. Prepend self and value. These are the arguments here. This is the node class. Okay, we are going to create node. If self dot head is none. Okay, we don't have any head. Then we want to create head. So self dot equals to new head, new node. So if we want to give any value here, we can give new node like we have any value 10, 20, 30. Okay, and self dot tail equals to new node. Okay, Otherwise, if you have any values in node, so new node dot next equals to self dot prepend prepend. We are going to insert a node data bg or find. We want to this is the link list. 2341. Now we want to add one more. Okay, this one. 231 is our old link list. Now we want to add one here. Okay. So inserting a node in front of the link list, we have 2, 3, and 4. Okay, in else condition, I am saying in else condition we have 2, 3, and 4. Here we want to add new node here. Here this is the hash. So we need to write like this. Okay. So new node. Okay. So new node dot next equals hash. Okay. This is a new node, and this is look at this wire. This is the next. Okay. New node dot next. Okay. So here we need to write new node dot next equals to self dot head. Okay. So new node dot next equals to self dot head. Okay, this one. Now this new node becomes head. Okay, so that's why we need to update it. Head equals to new node. So here you can see self dot head equals to new node, and now we need to increase length of this by one that we trade. I mean we will go another pointer. So dry run if you have head equals to initially you have head equals to and tail equals to and length equals to 0. So at we want 10, so new node equals to 10. List is entity initially, so head equals to 10, tail equals to 10. Okay, so head equals to this one 10 and none, and tail here, and length equals to 1. Now pre-append Tom 20, so new node down again 20, and list is not entity. New node dot next equals to old head, and head equals to 20. So here you can see the add 20 here, so have 20 and 10. Okay, so length equals to 2. Okay, and this is our new link list. Final link list, here you can see 30, 20, and 10. Similar applies, new node equals to 30, new node dot next, old head equals to 20, and head equals to 30. Length is 3, this is the new link list. 30, 20, and 10. Okay, head equals to 30, and tail equals to 10, and length equals to 3. Now I'm going to insert method. So here you can see this is the insert function, this is the argument, self, dash, and value. This is the node class. Okay, this is the object to node class. Now if cell dot head is none. Okay, initially cell dot head is none. So we are going to give head cell dot head equals to new node, and cell dot tail equals to new node. Okay, and L if index equals to 0 0. Okay, if index equals to 0 0, new node dot next equals to self dot head, and self dot head equals to new node. Okay, so here you can see temp node equals to we are going temp node. I mean self dot head equals to, now we give variable name temp node to the head. Okay, so we can move in whole linked list. So temp node equals to self dot node here 4 dash and then index minus 1. Okay, so this is the index, second last index in linked list. Okay, so temp node equals to temp node dot next. This is the next node of temp node. If you have head equals to temp node, then next node of head, okay, next node of head, it will become temp node dot next. Okay, so temp node equals to temp node dot next, and new node dot next temp, it becomes temp node dot next. So temp node dot next equals to new node, and that long length increase R1. Okay, so you can see here R1 insert method. Initially we have 10, 20, and 40. This is the tag. This is and length equals to 3. We will start value 30 at index 2. Okay, these, we will insert value equals to 30 at index 2. We want to insert 30 here at index 2, 0, 1, and 2. So we want to put 30 here in between 20 and 40 at index 2. So length equals to 3, and I create a new node. New node equals to 30. Node is created but not linked that. Okay, so check if list is empty. So list is not empty, skip that step. Okay, so here we are going to skip this step because list is not empty and we don't have index equals to 0. Okay, so check if inserting at head index equals to 0. So no, and we have index equals to 2. Okay, we don't have index 2 equals to 0, so we need to skip this step also. And okay, so here we can see uh, insert in the middle. Okay, so now we are going to insert in the middle. Here we see else condition. So start from temp node head. Temp node equals to head. Okay, so we took head equals to temp node, and value of temp node equals to 10. So traverse to previous node of length. So traverse to previous node of the target index minus 1 equals to 1. Target index minus 1 equals to 1. So loop run once temp node equals to temp node dot next equals to 20. This is the temp node equals to head. Okay, now temp node equals to temp dot next equals to 20. So we move on another value, another data. So link the new node temp node dot next equals to temp new node dot next equals to temp node dot next equals to 40. Now temp node dot next equals to new node. This becomes 20 30. So here equals to 20, 10, 30, sorry 10, 20, 30, 40, and 10. So now we are going to increase length. Final this transfer inside of this one. Length becomes 40 and insert a node 30 at the next. Summary of which is create a new node. The list is empty, insert at the head and tail. If index equals to 0, insert at head. Otherwise, traverse to previous node index minus 1. Link new node in between previous dot node and new node. New node dot next equals to next node and increase the length. Here you can see temp node equals to temp node next, and new node dot next equals to temp node next, and temp node dot next equals to new and increasing length again. Now we can see traverse of method. Okay, so here you can see we need to create a function. Traverse means we are going all pointer from linked list. So here we need to create one function traverse. Okay, so current equals to self dot head. So we are going to head equals we are going to create one variable current and current equals to self dot head. Okay, so this suppose that head equals to current. While current is not none. Okay, so current is not none, print current dot value. Okay, so after that current equals to current dot none. Okay, so we have our list is head 10, 20 and 30 and tell. So current head equals to 10. Look here, current is not none, okay? Current is not none, okay, because we have 10. So print 10 and move to the next, okay? So output equals to 10 and current equals to 20. So now current equals to 20, 20 become current. Now print 20 and move to the next, okay? Here you can see we are going to move current dot next. Move to the 30, so current equals to 30 and print 30 and move to the next. Now output 30 and current equals to 9. Import expression current equals to 9. Loop stop. Final step 20, 10, 20 and 30. Now we are going to use search method. Okay, so here you can see I'm going to create search function with the argument self and target. Target means like if you have value like target equals to 20, then we need to find out 20 in the given value. Okay. So here you can see current equals to self dot head. Okay, so we are going to take head equals to head is a current. Okay, suppose that we have a current variable which have head. Okay. Now index equals to 0. Okay, so while current is not none, okay, if current is not none, then we will proceed it again. If current dot value equals to target, okay, if this value in current is equals to target. Target means the value we are going to find it. Okay. If current value or target equal both are equal, then we need to return index of it. Okay. And current equals to current dot next and we increase the index value. Okay. If value doesn't equal to target value, then we move to the current equals to current dot next and we increase the index value. Otherwise, we need to return minus 1. Here you can see we have linked list has 10, 20 and 30 and tell dry an example size. We need to search 20 here, so here you can see current equals to 10, 10 and index equals to 0. Yes, we need to check because we are going to find 20 here, so here you can see 10 equals to 20. Okay, so our current dot value equals to 10 and target equals to 20. So both are not equal. Okay, so index become 1 and now current equals to current become 20. So check. Now we are going to check again. So here 20 equals to 20. Yes, so it will match. Now we say S and return 1 and output equals to 1 because it's S index. We find out 20 and then search now we are going to search 30. So here we can see at index 0 not match, at index 20 not match, at index 3 yes match. Now we need to return index of it. Okay. So output equals to 2. In case 3 we need to search 40. So here at index 0 not match, index 1 not match, index 2 not match. Current equals to none, loop stop and return minus 1 because we don't have any value like 40 in our linked list. Okay, so our output equals to minus 1. Okay, so here you can see this is the code. If you want to create a whole code, like this is a node class, this is a linked list class for 0 length, and this is the code for append. Okay, and this is for search. While current is not none, if current dot value equals to target with an index, otherwise current equals to current dot next index into 7. If we don't find search value in this linked list, we need to return minus 1. Okay, so here this is the object of linked list. Now we need to append. Here we are going to append and here we need to search. So our output equals to search element and the index. Okay, now we need to use get method. If we have index equals to minus 1, okay? Minus 1 means last index, then return tab dot tab. Tab because it's the last index, okay? Else index is less than minus 1, okay? Index is less than minus 1 or index is greater than self dot length, okay? Length of linked list, okay? So index is greater than self dot length, so we can return none, okay? Because we don't have an index greater than length, okay? So here after that we need to create current equals to self dot head, okay? I mean we have one variable current which has self dot head, okay? Current equals to self dot head, and I am going to apply loop here for dash and then index, okay? So current equals to current dot next, okay? Current equals to current dot next and return current. So this is the value we get. So you can see here this is the linked list have 10, 20 and 30. This is the test. Okay, length equals to 3. So page 1 get 0, index equals to 0, not minus 1 and not out of range. Okay, so current head equals to 10. Loop run 0 time, return current value 10. Okay, so output 10. Here you can see index equals to 1, current head equals to 10, loop run 1 time and current becomes 20 and return 20. Now the output is 20 and that's 2. Here you can see index equals to 2, current head equals to 10 and loop run 2 times. So current equals to 30 and return 30. Output node equals to 30. That minus 1 index equals to minus 1 is total case. Return tail and tail equals to 30. Output node equals to 30. And case 5 get 3 index equals to 3 and index greater than equals to length 3 invalid and return 9. Okay. So return now node at the given index and handle negative index, example minus 1 hotel and return none of the index. Here you can see whole example. This is the node class, this is the linked list class, this is the append, we already learned it, and this is the get. Okay, that means we get any value from this function. Okay, this is for example uses. This is the object for linked list. Here we are going to append value 20, 10, 10, 20, 30. Here we are going to get the value. Okay, now set value. So here this is the function, this is the self, and this is the index, and this is the value. This is the argument and parameter. Here you can see temp equals to self dot get index, self dot get index, and if temp self dot get index, we get an index from this method. Okay, this one from get. Okay, so we got index from that method. Here you can see temp equals to self dot get index. Okay, if temp, now we are going to apply condition. If temp dot value equals to value. Okay, return to true, otherwise return false. Okay. Here you can see this is suppose we have list has 10, 20, 30 and 10. Length equals to 3. Okay, so call get 1, so return node with the value 20. Okay, so we are going to set value. I mean we want to add 25 at index 1. Okay, so we get index 1 return node with the value of 20. Okay, so at index 1 we have 20 as a value. So temp equals to node 20. So update temp dot value equals to 25. So let's return 10, 20 and 30. Output equals to 3. Here you can see at index 1 we have 20. 0 at 0 we have 10 and at 2 we have 20. Okay, so now we want at 0 index value equals to 5. So here we can call get function and get 0 to return node with the value of 10. Okay, at 0 we have 10. So temp equals to node 10 and updated value temp at value equals to temp. Here you can see temp dot value. We got temp here from that value from that method we get index. Okay, So we got 0 index here, and it's here we can see 0 index and 0 index. The I need index 0 value of update with the new value. Okay, so this will update with 5. For export. Here you can see this is the functional access. Okay, this is the whole example, this is the node class, this is the linked list class, this is the pen, this is the get, this is the index, and this is the set. Okay, this is for example, this is where we are going to append, this is the for get, and this is the second line for set, again this is for get, and this is for set last line. Okay, so this is the result, this is the result. Now pop first method. Okay, so if we want to remove by argument from start of the linked list, we can use pop first method. Okay, so remove and return the first node from the head. Okay, handle empty list and single node list, update the head and length. Okay, so here you can see this is the pop function. If self.length equals to 0, return none. Okay, so because we have length equals to 0, we don't have any length, so that's why we need to return none. And pop node equals to self.head. Okay, so we are going to remove head, this one. Pop node equals to self.head because we want to remove head. I mean value from head. Okay, okay, if 0, if length equals to 0, then we need to return, and then if pop node equals to self.head. Okay, so if self.length equals to 1, then self.head equals to none, and self.head equals to none. Okay, if length equals to 1, then we need to update self.head equals to none and self.tail equals to none. Else self.head, if we have any value. Okay, so self.head equals to self.head.next. Okay, so pop node dot next. Pop node is head. Okay, so pop node dot next means a value next to the head, which is also none. And self.length decrease by -1 and return the pop node. Here you can see we have had 10, 20, 30 and tail and length equals to 3. Each block has a number, head point to the first block and tail point to the last block. Okay, so here you can see first pop first. Here pop node equals to head, so pop node equals to 10. Okay, because we have 10 as head, so move head to a head equals to head dot next. Okay, so head now move to the 20. So cut the length from 10. Okay, so pop node dot next equals to none. Okay, so this will become none. Now head cut from, I mean 10 cut from the linked list. Now our new head equals to 20 and next node of 20 equals to 30. Head 20 and 30. Decrease the length was 2 and return 10. Here you can see self dot head, we have self dot head equals to 10. Okay, now self dot head move to the 20 and cut the line from 10 form dot node that next equals to none, and that I mean length decrease by 1 and return the pop node and mean return the 10. Here we can see list after the operation has 20, 30. Tell length equals to 10. 2. Second pop first. Okay, if you want to remove second element from, I mean again head. So pop node equals to head equals to 20. Move head equals to head dot next. So here you can see head equals to head dot next. Okay, I mean move head at 30. Okay, here you can see head at 30. Head equals to head dot next 30 and head 30 first. Cut the link of 20. So pop node dot next equals to none and head equals to 30, length equals to 1 and return 20. Head equals to 20, 30 and tail length equals to 1. Now you can also pop third method by, if you want to remove again, so pop node equals to 30. which is the head. Since length equals to 1 and set both head equals to none and tail equals to none, length becomes 0 and return 30. Now list is empty, so head none and tail none, length equals to 0. Now you can remove fourth point, so list is already empty, length equals to 0, return 1. Okay, so now we can use pop method in which we remove the element from the last order linked list. Okay, here you can see the pop method. If length equals to 0, then we need to return none. Now pop node equals to self dot self, because we are going to delete from the last, so that's why we need to write like this self dot self. Okay, if you want to remove element from the starting of the linked list, then you need to write self dot head. If length equals to become self dot head equals to self dot self equals to none. So we don't have like length equals to 1 more. If we have length more than 1, now we need to use all this condition, else condition. Temp equals to self dot head. Okay, so while temp dot next is not set dot head. Okay, so temp equals to temp dot next and temp dot next equals to none. Self dot tail equals to temp and length decrease by 1 and return pop node. So you can see diagram, if we have had 10, 20, 30 and 10, length equals to 3 and we are calling pop. So here you can see temp now point to the first node 10. 10 equals to 10. Okay, so we are going to assign 10 as temp. So head equals to 10, 20 and 30 and 10. While temp dot next is not self dot self. Okay, so temp dot next is not self, not self. So temp dot next equals to 20. Okay, this is not a tail. Temp dot next is not a self dot tail, because tail is just 30. Not tail, so true, or we are going to insert in the loop. So temp equals to temp dot next inside the loop. So we can move temp to the next node 20. Okay, so here one new temp equals to 20. Now we can say the condition temp dot next equals to 30. This is the tail. Temp dot next is not a tail, harsh exit loop. Temp point to the second last node 20. So temp dot next equals to none. Cut the link to the old tail and we have head equals to 10, 20 and tail. So 30 is now disconnected. So after that, before self dot tail equals to 10, update tail to the second last node and 20. Tail equals to 20 and self length decrease by 1 and length equals to 2. Return pop node equals to 30. Final linked list, here you can see that 20, 10, 20 and 10. Length 20 and pop node equals to 30. Here you can see start from the head, move to the 10 and cut the last node. Here update the node, update the tail and decrease the length by 1 and return the pop node. Now this is the last one, remove the method. Okay, so here you can see remove method, this is the tail and this is the index. So index is less than -1 or index is greater than equal to length of self dot length. Okay, so return 1. If index is not 0, then self dot pop first. Okay, if our index equals to 0, then we are going to remove value from the linked list. If index equals to -1 or index equals to self dot length -1, so return self dot self. We are going to remove from the class. Here you can see previous node equals to self dot get index -1. Okay, so here we are getting previous index by using get method. Okay, so here you can see pop node equals to previous node dot next. Previous node dot next equals to pop dot next and pop dot next equals to none and self dot length -1 equals to 100 and pop. Here you can see diagram of this. This is the head, length equals to 4 and index equals to 2. We will remove index to value 30. This one. index validity. If index is less than -1 or index is greater than equal to self.9, return none is invalid. Index 2 is invalid and continue. Remove first node. So if index equals to 0, call for first. Index equals to index is 2, not 0. Skip, we can skip now. Remove last node. If index equals to plus or -1 or index equals to self dot length -1, call for index equals to 2, node not -1 or 2, we can skip. Remove node from the middle. So previous node equals to self dot get index dot minus, then get 1 node empty. Pop node equals to previous node dot net node 30 and node to delete. So skip the pop node. So previous node dot net equals to pop node dot net 20 and 30. 30 is now disconnected. So you can see still, and this is the pop node is 30 and this is the input. Cut the pop node. So pop node dot net equals to 9. So we disconnect. Decrease the now we are going to decrease length here and return the pop node here. And finally list after removal this one and then this one and remove like this. Okay. From the objective check if the index is valid, if index equals to 0, remove the head. Okay. By using pop first method. If index -1 or last, remove the tail pop. Otherwise in the index get the previous node. Index -1, skip the target node. Previous node dot net and equals to pop node dot net and disconnect for those for number to node dot net equals to 1 degree 1 and return row node. Okay guys, bye bye, take care. If you have any doubts, please do comment, share, subscribe, like. See you in next video.